Good day. This research is about the efficacy of cow manure versus chicken manure as fertilizer for mung bean or Vigna radiata. Prepared by our group consisting of Jason Lawrence Colima, Raizanel Hormano, Angel Lolo, Kirivan Paler, John Lloyd Sergio, and me, Alteo Montoyo. Background of the study. First bullet. Home gardeners like to use well-rotted manure since it is less odorous, more easily spread, and less likely to burn plants. Emily 2019. The use of manure as fertilizer dates the beginning of agriculture. Moreover, people who raise livestock and poultry have used manure as fertilizer, soil amendment, energy source, and even construction material. Manure contains many useful recyclable components, including nutrients, organic matters, solids, energy, and fiber. The next bullet, organic fertilizer are biodegradable, renewable, environmentally friendly, and also sustainable. Just as human needs essential minerals and nutrients for strong, healthy growth, so do the world's crops. Manure from cows and chickens have a lot in common. Both are some of the best resources of nutrients for organic crop farmers, making it easier to earn and maintain your organic planting. They both also increase your soil water retention. The next bullet, the poultry manure fertilized plants were the tallest as compared to cattle and inorganic manure. Michael at 2012 also reported that poultry manure treated plant gained maximum plant height as compared to inorganic fertilizer. This implies the soil is poor in nutrients and of low productivity, hence response to organic manure would be encouraged. Abogidi and Okonma 2012. Next bullet, fertilizer are used by farmers because they contain plant nutrients like nitrogen, phosphorus, and potassium. However, fertilizer prices are a problem for farmers. Prices have been rising in the international market owing to increased demand from countries as well as higher freight costs. Agricultural scientists are encouraged to establish an agricultural system which can lower production costs and conserve the natural resources. Therefore, recent interest in manuring has re-emerged because of the high fertilizer prices and importance of green manure. Lastly, farmyard manure and other types of manures maintaining long-term soil productivity besides meeting timely requirement of nutrients, Bocci and Tano 1994. The researchers chose mung bean because it typically germinates within 4 to 5 days. However, the actual rate of germination varies according to the amount of moisture introduced during the germination stage. Watering the bean seed often results to faster germination. Now here's Jason Klima for the theoretical framework.
Theoretical framework. In organic farming, there are many factors for the yield of agricultural crops. You take special care to select the right equipment in times for planting. But how do you choose the best organic fertilizer for organic farming? There are many elements to consider. However, two of the most common types of organic manure are chicken manure and cow manure. Both options are good, but it's helpful to know the exact differences to make the right choice. Dried poultry manure is 2 to 3 times as rich as cow manure in inorganic fertilizer content. Poultry droppings are better manure than cow dung or other farmyard manure in nitrogen, phosphorus, and potassium content, the element most deficient in Indian soil. Poultry produce about twice as much fresh dropping on a weight basis as fuel eaten. Poultry litter also may be converted to compost litter and used as animal feed. In animal farming, feed usually represents 60% to 70% of the total expenditure. Its feeding value and palatability could be improved, no doubt, by adding salt, other minerals, and molasses. Utilizing poultry manure or feed nutrient may help to alleviate pollution problems, diseases, feed costs, and increase the supplies of available nitrogen in essential mineral sources. Agricultural crops will naturally grow in different types of soils, but agriculturists know what kind of crop is best suited to what type of soil. With introduction of fertilizers, farmers could achieve higher yield of agricultural crops. In organic farming, you invest less but you obtain more and higher yield of agricultural crops. The conduct of this study would also be in reference to Liebig's law of the minimum. According to Liebig's law of the minimum states that the local yield of terrestrial plants should be limited by the nutrient that is present in the environment in the least quantity relative to its demand for plants' growth. And this statement has been confirmed worldwide. Due to the rising cost of commercial fertilizers in the international market, plus higher freight costs, agricultural scientists have resorted to adopt the organic type of fertilizer using animal manure. Average farmers have engaged in this system because of reduction costs and conserve the natural resources. The right time and equipment are to be considered in planting. Also, the best type of organic fertilizer to be used. The most common are chicken manure and cow manure. Other factors to be considered is the availability of the fertilizers, the benefits gained, and the effects of the natural environment. A theoretical framework is made to establish a study as to what type of animal manure is the most effective and efficient. And now here's Angel for the next slide.
According to the paradigm, the purpose of this study is to investigate and compare the effectiveness of three types of manure as plant fertilizers. This study has three variables: independent, dependent, and controlled. Cow manure, chicken manure, and mixed chicken and cow manure are the independent variables, while the dependent variable is the effect of the manure on the growth of the plant, and the controlled variables are the type of soil, the amount of fertilizer, and the number of seeds used in the study. The researchers will plant the mungo to personally monitor or observe how the manures affect its growth. For the next slide, let's have Alethea.
As shown in a research paradigm, our independent variable would be the types of fertilizer used, which is chicken manure, cow manure, and mix of chicken and cow manure. And for our dependent variable would be the growth of plant, which is mungo, number of leaves, size of leaves, and the height and diameter of stem. For a controlled variable will be the type of soil, amount of fertilizer, number of seeds, type of water, amount of water used, and time watering. Now here's John Lloyd for the statement of the problem.
Statement of the problem. This research will be conducted to assist the audience about which of these types of manure when used as organic fertilizer will be more beneficial in planting. This study aims to give more information about the factors that may affect crop health and productivity. 1. Is there a significant difference in the growth of plants with chicken manure in terms of A. Length and diameter of stem, B. Size of leaves, C. Number of leaves. 2. Is there a significant difference in the growth of plant with chicken manure versus mix of chicken and cow manure in terms of A. Length and diameter of stem, B. Size of leaves, C. Number of leaves. 3. Is there a significant difference in the growth of plants with cow manure versus mix of chicken manure and cow manure in terms of length and diameter of leaves, size of leaves, C. Number of leaves. 4. Is there a significant difference in the growth of plants with cow manure, mix of chicken and cow manure versus control group in terms of A. Length and diameter of leaves, B. Size of leaves, C. Number of leaves.
Scope and limitation of the study. The goal of this experimental research is to find out what manure is more efficient to use as a fertilizer, cow manure or chicken manure, environment manure, and know which manure is better to use for plants as a fertilizer. The research will solely present its conclusion based on the data obtained during the experiment. For the next slide, let's have Alethea.
For the research design, this study will use experimental research. The purpose of experimental research is to determine the relationship between two variables which is dependent and independent. This relationship is generally causal in nature. It must be measurable, capable of statistical analysis, and comparable. For our sampling technique, general observation of the effects of cow, chicken, and mix of chicken and cow manure as fertilizer for munggo or mangbin will be made at Kubi-Kubi Triples A Farm, is a barangay in the municipality of Nasipit, as shown in our Google map. Each member of the research will assign to plant the same kind of munggo but uses different kinds of manure as fertilizer in order to distinguish what's more effective as fertilizer for the munggo plant or mangbin. Equipment will be used in the research study are shovel, soil, munggo seed, water, and fertilizers, which will be cow, chicken, and mix of chicken and cow manure. Before planting the seed, it must be soaked in the water for about 15 minutes and then drain it after. Each type of manure was provided a flower pot to plant the munggo seeds. An additional flower pot was added for the control group. The planting soil in the pot will be watered until it is evenly moist, and the seeds to be planted 1 to 2 inches deep in the damp soil. The seeds were spaced 2 inches apart and set the rows 1 inch apart. The observation of the group in the plant will be recorded every 4 days. For 16 days to ensure the plant is observed well enough to see the effects to the different fertilizers used. The observation will be jotted down from day 1 until day 16 to have a total of 4 recorded data. Now here's Riza for the instrument.
For our research instrument, we decided to use one-way analysis of variance or ANOVA. One-way analysis of variance is used to see if the means of 3 or more independent, unrelated groups differ statistically. In this study, it was used to compare the means of the dependent group in order to determine whether there is statistical evidence that the associated population means are significantly different in terms of number of leaves, size of leaves, the height of stem, and the diameter of the stem. In our data gathering procedure, we follow 6 steps in our pre-experimentation. Step number 1, preparation of mung beans. Step number 2, buying flower pots in the market. Step number 3, gathering and mixing chicken manure with soil for chicken manure treatment. Step number 4, gathering and mixing cow manure with soil for cow manure treatment. Step number 5, mixing cow manure, chicken manure, and soil for mixed treatment. Step number 6, preparation for pure soil for control group. During experimentation, we follow 4 steps. Step number 1, soak mung beans in the water for about 15 minutes and then drain it after. Step number 2, planting 5 mung beans on each treatment. Step number 3, the researcher will monitor the plants on a daily basis, including watering them with the same amount of water at the same time for the next 16 days. Step number 4, the researcher will record the plant's growth from day 1 through day 16. For our post-experimentation, we follow 4 steps. For our step number 1, the collected data will be analyzed further by the researcher. Step number 2, the researcher will use one-way analysis of variance or ANOVA, see if the means of groups differ statistically. Step number 3, the result will be used by the researchers to build a conclusion among the organic fertilizer used to determine which fertilizer is more efficient when used as fertilizer. For our data analysis, Kira Vinpalar will be explaining this.
Data analysis. To identify the effects of manure on plant growth in each plant, an observation table was made to measure the plant's number of leaves, size of leaves, height of stem, and diameter of stem. It is recorded twice a week to make sure that the plant is well observed enough to see the effects of the various fertilizers applied. One-way analysis of variance, or ANOVA, was also used to determine whether there is statistical evidence that the associated population means are significantly different. Next slide. Recorded data on effects after day 4. For number of leaves, chicken manure scored an average of 0.4, cow manure scored an average of 2, mixed chicken and cow manure scored an average of 0.8, and control group scored an average of 2. For size of leaves, chicken manure scored an average of 37.68 millimeters, cow manure scored an average of 99.02 millimeters, mixed chicken and cow manure scored an average of 47.02 millimeters, and control group scored an average of 85.91 millimeters. For height of stem, chicken manure scored an average of 56.40 millimeters, cow manure scored an average of 74 millimeters, mixed chicken and cow manure scored an average of 50.40 millimeters, and control group scored an average of 83.6 millimeters. And for the diameter of stem, chicken manure scored an average of 1.48 millimeters, cow manure scored an average of 2.08 millimeters, mixed chicken and cow manure scored an average of 1.86 millimeters, and control group scored an average of 2.11 millimeters. Next slide. Recorded data on effects after day 8. For number of leaves, chicken manure scored an average of 2, cow manure scored an average of 2, mixed chicken and cow manure scored an average of 2, and also control group scored an average of 2. For size of leaves, chicken manure scored an average of 562.03 millimeters, cow manure scored an average of 480.68 millimeters, mixed chicken and cow manure scored an average of 577.95 millimeters, and control group scored an average of 501.88 millimeters. For height of stem, chicken manure scored an average of 210.02 millimeters. Also, cow manure scored an average of 210.2 millimeters. Mixed chicken and cow manure scored an average of 203 millimeters, and control group scored an average of 239.2 millimeters. And for the diameter of stem, chicken manure scored an average of 2 millimeters, cow manure scored an average of 1.92 millimeters, mixed chicken and cow manure scored an average of 133 millimeters, and control group scored an average of 2.07 millimeters. Next slide. Recorded data on effects after day 12. For number of leaves, chicken manure scored an average of 2, cow manure scored an average of 2, mixed chicken and cow manure scored an average of 1.2 millimeters, and control group scored an average of 2. For size of leaves, chicken manure scored an average of 738.78 millimeters, cow manure scored an average of 722.19 millimeters, mixed chicken and cow manure scored an average of 517.01 millimeters, and control group scored an average of 122.43 millimeters. For height of stem, chicken manure scored an average of 219.4 millimeters, cow manure scored an average of 221.4 millimeters, mixed chicken and cow manure scored an average of 142.8 millimeters, and control group scored an average of 246.8 millimeters. For the diameter of stem, chicken manure scored an average of 2.09 millimeters, cow manure scored an average of 1.81 millimeters, mixed chicken and cow manure scored an average of 1.21 millimeters, and control group scored an average of 1.72 millimeters. Next slide. Recorded data on effects after day 16. For number of leaves, chicken manure scored an average of 4.1, cow manure scored an average of 3, mixed chicken and cow manure scored an average of 1.6, and control group scored an average of 1.6. For size of leaves, the chicken manure scored an average of 1,086.66 millimeters, cow manure scored an average of 949.83 millimeters, mixed chicken and cow manure scored an average of 604.18 millimeters, and control group scored an average of 653.37 millimeters. For height of stem, chicken manure scored an average of 232.8 millimeters, cow manure scored an average of 245.2 millimeters, mixed chicken and cow manure scored an average of 150.5 4 millimeters, and control group scored an average of 208.6 millimeters. And for the diameter of stem, chicken manure scored an average of 2.12 millimeters, cow manure scored an average of 1.85 millimeters, mixed chicken and cow manure scored an average of 1.25 millimeters, and control group scored an average of 1.48 millimeters. Next is statistical treatment. Statistical treatment. Table 1. Analysis of variance on the results of day 4. For the analysis of variance of number of leaves, treatment chicken versus cow manure has a p-value less than 0.05, which results that it has a significant difference. Also, treatment chicken versus control has a p-value less than 0.05, which results that it has a significant difference. And for other treatments, they scored a p-value greater than 0.05, which results that it has no significant difference in terms of number of leaves. For analysis of variance of size of leaves, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of size of leaves. For analysis of variance of height of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of height of stem. For analysis of variance of diameter of stem, all treatment groups scored a p-value greater than 0.05, which also results to no significant difference. Therefore, all treatment groups had no significant difference in terms of diameter of stem. Next slide. Table 2. Analysis of variance on the results of day 8. For analysis of variance of numbers of leaves, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of number of leaves. For analysis of variance of size of leaves, all treatment groups scored a p-value greater than 0.05, which also resulted to no significant difference. Therefore, all treatment groups had no significant difference in terms of size of leaves. For analysis of variance of height of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of height of stem. For analysis of variance of diameter of stem, all treatment groups scored a p-value greater than 0.05, which also results to no significant difference. Therefore, all treatment groups had no significant difference in terms of diameter of stem. Next slide. Table 3. Analysis of variance on the results of day 12. For analysis of variance of number of leaves, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of number of leaves. For analysis of variance of size of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of size of leaves. For analysis of variance of height of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of height of stem. For analysis of variance of diameter of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of diameter of stem. Next slide. Table 4. Analysis of variance on the results of day 16. For analysis of variance of number of leaves, treatment chicken versus mixed manure had a p-value less than 0.05, which means that the results show that this is significantly different. Treatment chicken versus control has a p-value less than 0.05, which results that it is significantly different. Treatment cow versus mixed chicken and cow manure has a p-value less than 0.05, which means that the result is significantly different. Treatment cow versus control also has a p-value less than 0.05, which means that the result is significantly different. And for the other treatments, they scored a p-value greater than 0.05, which means that it has no significant difference in number of leaves. For analysis of variance of size of leaves, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of size of leaves. For analysis of variance of height of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of height of stem. Lastly, for analysis of variance of diameter of stem, all treatment groups scored a p-value greater than 0.05, which results to no significant difference. Therefore, all treatment groups had no significant difference in terms of diameter of stem. Next is results and analysis. Results and analysis. The results show that there is a statistically significant difference in the quantity of leaves on day 4 between cow manure and chicken manure. There is a statistically difference in the number of leaves between the treatment's chicken manure and control group on day 4. Furthermore, there is a statistically significant difference in the number of leaves on day 16 between chicken manure and mixed chicken and cow manure. Moreover, there is a statistically significant difference in the number of leaves on day 16 between chicken manure and control. Lastly, on day 16, there is a statistically significant difference in the quantity of leaves between cow manure and mixed chicken and cow manure. Next, we have John Lloyd for the summary.
Summary. The findings indicate that between cow manure versus chicken manure has a statistically significant difference in terms of number of leaves on day 4. Treatment's chicken manure versus control group has a statistically significant difference in terms of number of leaves on day 4 also. Moreover, chicken manure versus mixed chicken and cow manure has a statistically significant difference in terms of number of leaves on day 16. Further, there is a statistically significant difference between chicken manure versus control in terms of number of leaves on day 16. Among cow manure versus mixed chicken and cow manure has also a statistically significant difference in terms of number of leaves on day 16. Further, between cow manure versus control group also has a statistically significant difference in terms of number of leaves on day 16. Lastly, in terms of size of leaves, the height of stem, and the diameter of stem showed no significant difference between all treatments grouped in all days observation. Angel will be explaining the next slide.
Conclusion. In this study, the researchers aim to use different kinds of manure: cow manure, chicken manure, and mixed chicken and cow manure, when used as organic fertilizer to identify what will be more efficient in planting. The researchers test the significant difference between all treatment groups in terms of number of leaves, size of the leaves, and the height of the stem, and the diameter of the stem. The researchers use one-way analysis of variance, or ANOVA, to compare the means of the dependent group in order to determine whether there is a statistical evidence that its associated population means are significantly different. The level of statistical significance was expressed as a p-value between 0 and 1. A p-value less than 0.05 statistically significant and p-value more than 0.05 not statistically significant. For the next slide, let's have Jason.
Recommendation. For students, this study may help them provide new methods, approaches, and techniques to attain the effectiveness for their future research. For farmers, the findings of this research is very important by providing information necessary to meet the solution of producing higher crop yields using this type of organic farming with less production and labor cost. Farmers will benefit and gain more income and improve their quality of living. For poultry and livestock farmers, they can venture business diversification by agricultural crop farming, side by side using their own animal manure as organic fertilizer. And based on the result of the experiments, it is viable for agricultural farmers to promote organic farming, while it is known that inorganic farming has various adverse effects on nature such as agricultural waste, pesticide pollution, and decreased soil fertility. The development and promotion of organic farming will be much appreciated with the aid or help from the government and private sector. And that's all for our presentation. Thank you.